Hello friends, in this session we will see how to draw polar plots when we have zeros as well in the transfer function. Let us begin. Yes, so if you just observe here, we have taken this 0. What is that 0? That 0 is nothing but this one, minus 1 by tau 2, right? That is our 0. Yes, along with that, they have also provided us with this pole zero plot. Why? Because we know that in order to find the starting direction, we actually need the pole zero plot of the loop gain, right? Yes. Now, the first step or the zeroth step is what? To replace s by j omega. So, yes, if we replace s by j omega, what do we get is gh of j omega is equal to, yes, j omega tau 2 plus 1 upon j omega squared into j omega tau 1 plus 1. Is that correct? Yes. Now, if you just see here, if you just again make it more simplified, then it becomes j omega tau 2 plus 1 divided by, if you see, this j omega squared. If you remember that, yes, j is equal to under root of minus 1, right? We have already studied it in our mathematics in a topic called as complex numbers. So if you just square on both sides, you get j squared equal to minus 1, right? Yes, so just see here, you have got this j squared, so that j squared is going to become minus, so we have minus omega squared into what? Yes, we have got j omega tau 1 plus 1, so it is j omega tau 1 plus 1. Now, how much is the m is what? M is the magnitude. If you want to do that for this particular numerator, if you see, this 1 is the real part and this omega tau 2 is the imaginary part. So yes, if you know that the magnitude is what? Magnitude is always under root of real part squared plus imaginary part squared. So if I take under root of real part is what? 1. So if I take 1 squared, I get 1 plus imaginary part squared. What is imaginary part? It is omega tau 2. Omega tau 2 squared is nothing but what? Omega squared tau 2 squared. Is that correct? Yes. Now divided by the same thing, divided by what? Divided by what? Yes. Minus omega square. What is the magnitude of minus omega square? It is going to become plus omega squared, right? Because mod of let us say mod of minus 2 is what? You know that mod of minus 2 is 2. So similarly, what is mod of minus omega squared? It is nothing but plus omega square. That's it. Because whatever comes out of the mod becomes positive, right? So this is going to be omega squared into under root of what? 1 plus, yes, this is the real part, 1 is the real part, so I've got this 1 squared plus, if you think of this omega tau 1 is the imaginary part, so it is going to become under root of real part squared plus imaginary part squared. Imaginary part is what? Omega tau 1, so it becomes omega squared tau 1 squared. Is that correct? Yes. Now, how much is the angle? How much is the angle phi? Angle phi is what? Yes. For the numerator, if you see, for the numerator, what is the numerator? Yes, this is the numerator. This is the numerator. For the numerator, if you see, we know that always the angle is going to be what? Tan inverse of imaginary part by real part. So if you see, what is imaginary part here in the numerator? For numerator, it is going to be omega tau 2, right? And the real part is 1. So here what I get is, for the numerator, the angle that I get is tan inverse of what? Omega tau 2 upon 1, which is nothing but tan inverse of omega tau 2, right? Which is the imaginary part. Now, next is what here? Yes, next is minus. Why minus what? Yes, see, you have got why minus, because this numerator has to be shifted up, right? These numerator angles, whatever this angle contribution is there because of this numerator, that has to be taken to the right. So if you see, we have got this minus omega square. What does that mean? Minus sign indicates that it is going to be 180 degrees. So 180 degrees down in the denominator, which means when it goes in the numerator, it is going to become minus 180 degrees. So here I am going to have minus 180 degrees, right? already we have seen this, right? Basics. Now anyways, what about the second term? In second term you have got imaginary part as omega tau 1, so it becomes minus tan inverse of, what do you say, omega tau 1. Is that correct? Yes. Now the step 1 which we follow is what? M0 and M infinity. Let us try to do that. Yes, so in step 1 what we find is M0 and M infinity. What is M0? M0 is the magnitude at omega equal to 0. How much is the magnitude? Let us see. If you replace omega equal to 0, what do you get there? You get there as, see, in this particular magnitude equation, if you put omega equal to 0, right? So you get what? You get under root of 1 plus 0 divided by 0, under root of 1 plus 0. What does that mean? Anything divided by 0 is going to be what? Infinity. So here what you get is infinity, right? That is your M0. What about M infinity? M infinity is what? M at omega equal to infinity. What does that mean? That is going to be equal to what? If you replace that in this equation of magnitude, what you get is under root of 1 plus infinity, right, divided by infinity into under root of 1 plus infinity. Now if you see, you are getting almost this infinity by infinity form, right, which is the indeterminate form, means this form cannot be determined. So in such a case, what are we supposed to do? You please take the omega common. How to take that? Let us see. You have got this M, right? What is M? M is nothing but under root of 1 plus omega squared tau 2 squared. Is that correct? Yes. Divided by, you have got omega squared into 1 plus omega squared tau 1 squared, right? Now the first thing, because see, if by some chance I can eliminate this omega squared, in the sense, you please take this omega squared out. Which one? If you take this omega squared out of the bracket, what do you get here? Let us see. If you take this omega squared out, what do you get then? You get that M equal to, if you just take this omega squared out, it becomes omega, right? Omega squared becomes omega, and inside that root, what do you get is, you get 1 by omega squared plus tau 2 squared. Is that correct? Yes. Now that thing divided by omega squared, which is already there in the numerator, divided by 1 plus omega squared tau 1 squared. Is that correct? Yes. If you don't understand this, you please keep this omega again inside. Then yes, then at the end you will get this particular expression itself. Anyways, so if you just say here, this omega and this one gets cancelled, so you have got this 1 by omega, right? Now if you replace M infinity, if you try to find M infinity, what do you get here? In the numerator you have got 1 by infinity plus tau 2 squared, right, divided by, here you get infinity under root of 1 plus infinity. It's okay, there is no problem with the denominator, because denominator term is going to be infinity. What about the numerator term? 1 by infinity. 1 by infinity is going to be 0, right? Then you have got this plus tau 2 squared, which is nothing but tau 2. So tau 2 by infinity is going to be what? 0. So you understand that M infinity is 0. So M infinity is equal to 0. That is what we have understood. Similarly, if you see, M0 is equal to infinity, right? Yes. Now if you remember, I told you that we can apply the next steps when M0 is greater than M infinity. If you see again, M0 is infinite and M infinity is going to be 0, which means this criteria of M0 greater than M infinity has been satisfied, which means the next steps can be applied. Now the step 2 is what? If I think of step 2, step 2 is to find phase, that is phi 0 and phi of infinity. What is phi 0? Phi 0 means phi at omega equal to 0. Let us put that. So you get that tan inverse of, if you place it in this equation, if you place, yes, so you get tan inverse of 0 minus 180 degrees minus tan inverse of 0, right? So what do we get here? Tan inverse of 0 is going to be 0, tan inverse of 0 is going to be 0, so here we have this minus 180 degrees. What does this mean? That phi 0 is going to be minus 180 degrees. Very easy. Now let us find phi of infinity. Phi of infinity is equal to what? Yes, it is going to be phi at omega equal to infinity, which is equal to what? Yes, which is equal to, let us put that. So you get tan inverse of infinity minus 180 degrees minus tan inverse of infinity, right? Yes, now we know that tan inverse of infinity, this is going to be what? This both get cancelled, right? Yes, so what you have left is this one, minus 180 degrees. So you have got this phi infinity is going to be minus 180 degrees, right? Now yes, you have these things. You have got this phi 0, you have got this phi infinity. Now important for me is the ending direction and starting direction. If you think of step 4, let me do it here only so that you will understand what I'm trying to do. Step 3, if I think of step 3, what is that step 3? Step 3 is nothing but ending direction, right? And that ending direction is given by phi infinity minus phi 0. Is that correct? Now if you just replace that, yes, phi infinity is going to be minus 180 degrees minus of minus 180 degrees, which is equal to 0. If you remember, I had told you that subtraction if the subtraction is positive, then we say that it is going to be anti-clockwise, right? And if the subtraction is negative, then we say that it is going to be clockwise direction. But we had not discussed that if it is equal to 0, then what is going to happen, right? So for time being, we cannot comment on ending direction, cannot comment. That is what I will write. We will see that afterwards. How to do that, I will tell you. Anyways, let us think of step 4 now. Yes, if you think of step 4, step 4 gives you the starting direction, right? And if you see, if you observe, this is the pole 0 plot, right? This is the pole 0 plot. In that pole 0 plot, if you observe, it is 0. What did I say there? I had told you already that whatever is there on the imaginary axis as well as on the right half, you have to ignore. So you have ignored it, right? Now you have to only think of this particular, what is there on the left half of S plane, right? So if you just see here, what 0 is closest to the origin, right? 0 is closer to the origin. What does that mean? If 0 is closer to the origin, it means that starting direction is anti-clockwise. If in case this pole was closer to origin, then starting direction would have been what? Clockwise, right? So for time being, if you see, we have 0 which is closer to this origin, which means starting direction is going to be anti-clockwise. Now let us try to draw the polar plot, right? Yes. Now, yes, if you see that, yes, starting direction is anti-clockwise, but before that, what is there at starting, we have to see. Yes, if you see m0 at omega equal to 0, your magnitude is infinity and your angle is what? And your angle is minus 180 degrees, right? m0 and phi 0, which is what? Omega equal to 0, your m is going to be infinity and this is minus 180. So what does that mean? That starting point is here, right? Or the starting point can be here. Is that correct? Yes. But if you see that the starting direction is anti-clockwise, if the starting direction is anti-clockwise, which means I have to move in this direction or not? This direction I have to move, right? Which means I cannot move in this direction. This direction is not applicable, which means I have to move in this direction only. Which means that yes, this is going to move in this direction. So this is the valid starting point. Yes, right. Minus 180, because this is minus 180 degrees. Let me just put the angle. This is 0. This is minus 90 degrees. This is minus 180 degrees. And this is minus 270 degrees. Right? Yes. Now, it will end where? It will end at, if you see, m infinity is 0, and that angle is also minus 180 degrees. That is the thing. No, see here, magnitude at infinity is 0, and the phase at infinity is minus 180 degrees, which means it has to end at this point, which is the origin. Right? Now the fact is, either it can go this way or it can go this way, green. Getting my point, right? Either it can go in the blue direction or it can go in the green direction, right? Because these are the only two possibilities which can happen, right? Now we will see if the first possibility, if this blue is applicable or not. If you just keenly observe here, you will observe that there is intersection of that particular blue plot in minus 180 degrees axis, right? So it means that I let us check that if there is any frequency, let us check that if there is any frequency at which minus 180 degrees angle occurs, any frequency at which minus 180 degree angle occurs. If that occurs, which means blue is right. So in order to check that, we will use our angle criteria. What is that angle criteria? Our equation of this phi. Let us use that and try to find. Yes. So our phi is what? Phi is nothing but, right? Yes, definitely. Now I need to find value of frequency for which angle is 180 degrees. So let me just put phi as minus 180 degrees, which is equal to, yes, now tan inverse. If you remember the formula, what is that? Tan inverse A minus tan inverse B is equal to tan inverse of A minus B upon 1 plus AB. That is what we have seen. So if I just apply that here, if I consider that this is our A and if I think of that this is our B, then it is going to be tan inverse of A minus B. So A is omega tau 2 minus B is omega tau 1 divided by 1 plus A into B. What is A? A is omega tau 2 into omega tau 1. So it means omega squared into tau 2 into tau 1. Is that correct? Yes. Now, if you remember, I had already told you that whenever angles are like, minus 180 degrees or 0 degrees or 360 degrees, then in such a case, we equate numerator to 0, right? We equate numerator to 0. By the way, this minus 180 degrees is also there, right? So if you see here, because this minus 180 degrees is also there, so this minus 180 degrees and this minus 180 degrees will get cancelled. So what do you have is, you have this tan inverse of omega tau 2 minus omega tau 1 divided by 1 plus omega squared tau 2 into tau 1 is equal to 0, which means that this numerator has to be 0 such that the whole term becomes 0, because we know that tan inverse of 0 is equal to 0. Is that right? Yes. So if I just put that, I will get omega tau 2 minus omega tau 1 is equal to 0, which means omega tau 2, which means omega equal to 0, right? But if you see that, omega equal to 0 is already taken as the starting point, right? So you just cannot use that. Why? Because we know that when omega equal to 0, already we know that magnitude is infinity, right? So which means that there is no frequency, at which minus 180 degrees angle has been found, which means that this blue plot is not applicable. Which means blue is rejected. Blue plot is rejected. What does that mean? It means that a green plot has been achieved. What is that? Let me draw it again neatly. So the final polar plot will look like this green. This is your final polar plot, where this is omega equal to 0 and this is omega equal to infinity. Is that correct? Yes. So this particular plot is valid, which is green, and this blue has been disapproved. Anyway, so now let us think of another example. Let us think of that. Yes. So if you see that in second example, if you see, we have taken two zeros. In the first example, if you see, we had considered only one zero, but here we have taken two zeros, right? So the first one, yes. So the first thing we do is we find gh of j omega. What is that equal to? It is nothing but, yes, just replace s by j omega. So if you replace that, what you get is j omega tau 1 plus 1 into j omega tau 2 plus 1 divided by omega squared into j omega tau 3 plus 1. Is that correct? Yes. Now, if you think of the magnitude, how much is the magnitude? How will you get the magnitude? Magnitude m is equal to what? Yes. If you say here, this is the imaginary part and this is the real part. So it is equal to what? Under root of. So let me keep a big under root because it's going to be multiplied only, right? So it is what? Under root of what? Yes. Real part squared plus imaginary part squared. So if you think of, yes, let me just take this. So if you think of this omega tau 1, so it becomes omega squared tau 1 squared plus 1, right? Multiplied by again, you are going to have this one. So you have, what do you say, omega tau 2, which is the imaginary part, and you have this one, which is the real part. So again, under root of, what do you say, real part squared plus imaginary part squared, or you can say omega squared tau squared plus 1. This completes the numerator. Now if you think of the denominator, what's the denominator there? Denominator is going to be what? What is the magnitude of omega squared? Omega squared only. So that is going to be omega squared. It will remain as it is, right? Multiplied by under root of, yes, because this is complex. This term is complex, right? So it becomes under root of real part squared plus imaginary part squared. So this is omega tau 3 the whole squared plus 1. So it becomes omega squared tau 3 squared plus 1. This is nothing but the magnitude. Now if you think of phase, how much is the phase? Phase phi is going to be what? If you see the numerator, it is what? J omega tau 1 plus 1, right? So here if you see, first angle that you get, angle contribution because of this first green, is going to be what? Tan inverse of imaginary part by real part. What is imaginary part? Imaginary part is omega tau 1, and whereas real part is 1. So it is okay. So what you get is tan inverse of what? Imaginary part upon real part. So what is imaginary? Imaginary part is omega tau 1 upon 1. That is omega tau 1, right? Plus, what is there? You have this one. So angle contribution by this one is going to be again tan inverse of imaginary part by real part. Imaginary part is omega tau 2. So it becomes plus tan inverse of imaginary part is omega tau 2 upon 1. Is that okay? Yes. Now again, omega squared. What is angle contribution because of omega squared? 0, because it is just a simple magnitude, right? Then what do you have is minus, if you say here, since this is s squared, it is going to be j omega the whole squared, and we have already seen that j omega the whole squared will be nothing but minus omega squared. So here I am going to have minus omega squared. So the angle contribution because of minus omega squared is going to be what? Minus 180 degrees, right? So here we get minus 180 degrees minus again. If you think of this one, here again this is imaginary part and here this is real part. So you get minus tan inverse of imaginary part upon real part. Imaginary part is omega tau 3 by 1. So this is the phase phi. Whereas on top of that I have also found out the magnitude. Now step 1. Step 1 is what? Step 1 is to find the magnitude at omega equal to 0 and magnitude at omega equal to infinity, which is nothing but m0 and m infinity. So yes, let us start with that. So step 1 is what? To find m0 and m infinity. What is m0? M0 is nothing but magnitude at omega equal to 0, which is equal to what? Let us see. So if you replace in place of m, this is m, right? Here if you put omega equal to 0, then whatever you get is nothing but m at omega equal to 0. So it is going to be what? It is going to be under root of 0 plus 1 into 0 plus 1 divided by 0. 0 into 0 plus 1. Anything divided by 0, if you see, it is going to be infinity. So here m0 is going to be infinity. What about m infinity? M infinity is what? Magnitude at omega equal to infinity. What is that again? M is what? Yes, if you put down that one, so you get what? Now see, what you have here is very interesting again, because in the numerator also you have got this omega term, and in denominator also you have got this omega term, which means what? Which means again you will be having infinity by infinity condition, right? So if you just see here, if you can just take this omega squared out, right? So yes, let me just take that. Yes, see, let me just firstly write down that magnitude. It is what? Under root of omega squared tau 1 squared plus 1 into omega squared tau 2 squared plus 1 divided by omega squared into omega squared tau 3 squared plus 1, right? From the numerator, if I take out this 1 omega squared out, then I will get 1 omega, because this is square root, right? Anything which comes out of square root will be again square root. So omega square root is going to be again omega, whereas here again this omega square will become this. So let me just do that one by one. If I just consider of this first term, what do I get? I am going to get this omega into under root of, yes, if you think of the first term only, then in first term you will be getting tau 1 squared plus 1 by omega squared, right? Again multiplied by, if you again take this one out, then you get one more omega, so this becomes omega squared into tau 2 squared plus 1 by omega squared. Is that correct? Yes. Now divided by the whole thing, divided by what? Omega squared into omega squared tau 3 squared plus 1. So omega square cancel. Now if you put omega equal to infinity, then what you get is, then you get under root of, see, denominator definitely you are going to get infinity only, because this omega square will become infinity. So it is going to be, denominator is 100% infinity, but on top also, on the numerator also, if you see, what you will get then is going to be tau 1 squared plus, if you put 1 by omega squared, if you put omega squared as infinity, omega is infinity, if you put here omega is infinity, then it becomes 1 by infinity. 1 by infinity is going to be 0. Then again multiplied by, you have got this tau 2 squared, right? Plus, if you think of this omega squared, if you put omega equal to 0 here, you will again equal to infinity here, you will again get 1 by infinity, which is equal to 0. So anything upon infinity now is going to give you 0. So m of infinity is going to be 0. Again, if you observe, what do you observe? You observe that m0 is greater than m infinity, which means next steps can be followed, right? Now step 2. Yes, if you think of step 2, in step 2 we find phi 0 and phi infinity. If you think of phi 0, phi 0 is what? It is angle at omega equal to 0. How much is the angle? How much is the angle? If you see, let me just take this. So if you just replace everything by 0, this one 0, this one 0, this one 0, so you get tan inverse of 0 plus tan inverse of 0 minus 180 degrees minus tan inverse of 0. So you get, so all of them, this becomes 0, this becomes 0, this becomes 0. So all of them become 0 and only except this minus 180 degrees. So you get phi 0 equal to minus 180 degrees, right? Starting angle you have got. Now let us think of phi of infinity. What is angle at infinity? Phi at infinity is nothing but what? Angle at omega equal to infinity. How to find that? Yes, again if you put tan inverse of, yes, infinity, right, plus tan inverse of infinity minus 180 degrees minus tan inverse of infinity. How much is tan inverse of infinity? Tan inverse of infinity is nothing but pi by 2, which is nothing but 90 degrees. So if you see here, this tan inverse of infinity, this one and this one will get cancelled, right? This tan inverse of infinity will give you 90 degrees, so you get 90 degrees minus 180 degrees. 90 degrees minus 180 degrees is going to be minus 90 degrees. So this is going to be phi infinity. This is going to be phi infinity. Now the step 3 is what? Ending direction. Let me do it here only. So step 3 is going to be ending direction. If you think of ending direction is going to be what? Phi naught minus phi of infinity minus phi of 0, which is equal to what? Phi of infinity is minus 90 degrees minus of minus 180 degrees, which is equal to plus 90 degrees, which is what? Positive. Hence what do we get here is anti-clockwise direction. So the ending direction is going to be anti-clockwise. That is what we have concluded from step 3. Now if we think of step 4, what happens in step 4 is, in step 4 I am interested in this starting direction, right? So this is the pole 0 plot, right? If you see, whatever is there on the imaginary axis and on the right half, that is what we are going to ignore, right? We are not interested in it, right? Now the first thing, so if you see here, the 0 is closer to the origin, 0 is closer to the origin, which means what? Starting direction is anti-clockwise. Starting direction is anti-clockwise. So starting direction is going to be anti-clockwise direction. Now as simple as that, we will just try to plot the plot. So this is our GH plane. This is nothing but our GH plane. Is that correct? Yes. Now, if you try to plot it, if you see what happens at omega equal to 0. At omega equal to 0, magnitude is infinity, and omega equal to 0, angle is going to be minus 180 degrees. So, let me just firstly draw these angles, put these angles. Angles are, here is 0 degrees, so here is minus 90 degrees, minus 180 degrees, and here is minus 270 degrees, right? Now, if you see here, magnitude at 0 is equal to what? It is infinity. Angle at 0 is going to be minus 180 degrees. So yes, definitely it has to start here. Minus 180 degrees is the angle and this is the starting. Right? Yes. Now, what is next then? The next thing we have to see is the ending point. Ending point is what? Ending point is magnitude at infinity is what? Magnitude at infinity is 0. Right? Similarly, angle at infinity is going to be minus 90 degrees. So yes, definitely this is going to be here. Right. Now, if you think of starting direction is anti-clockwise direction they have seen, which means anti-clockwise is this direction, which means this has to go in this direction only, right? Anti-clockwise direction only. Now, if this is going in anti-clockwise direction, what about ending direction here? ending direction here, ending direction is also anti-clockwise, which means here also it has to be anti-clockwise like this. This is going to be anti-clockwise, right? So if you see here, you have omega equal to 0, and here you have omega equal to infinity. Am I right? Yes. Now what do you understand from this? The most important thing is that, see, yes, if you see the first example where we had only one zero, if you consider the first one where we had only one zero, what was the ending angle, ending point angle? See, ending point angle was minus 180 degrees, right? But when you have two zeros, when you have two zeros, what has happened? Ending point angle has become minus 90 degrees, which means that if I add a zero in the system, then ending direction angle will be reduced by 90 degrees, because initially if you see the first case wherein we had only one zero, the ending angle was what was equal to minus 180 degrees. But now when you have increased the number of zeros, that means when we have second one as well, then in that case the ending direction angle is equal to minus 90 degrees, which means what? Which means that when I add a zero in the system, then ending direction angle will be reduced by 90 degrees. You please make a box for it. This is a very important thing. So in such a way, we have seen that what happens when we have zeros in the system. Now I will be much more interested in another example wherein I have three poles at origin and then I have one zero, only one single zero. Let us see that question as well, because so that will be a example sort of, right? Because there we will be taking some values of tau 1, tau 2 and all, right? Let us take that example first. Yes. So given that loop gain gh is equal to s plus 2 upon s cube, right? So the first thing we do is gh of j omega. What is gh of j omega? J omega, which means just replace s by j omega. So if you see, you will get j omega plus 2 divided by j omega the whole cube, right? Right, which is nothing but equal to 2 plus j omega divided by minus j omega the whole cube, which means omega cube is going to be there. And what about j cube? J cube is nothing but equal to minus j, right? So here I am going to get minus j. Is that correct? Yes, because this j cube, if you see, that can be written as j squared into j, right? And j square is nothing but minus, so it becomes minus j. So j cube can be written as minus j as well. So that is what I have written. Now what about the magnitude and angle and the phase angle? If you see magnitude m is going to be what? Under root of real part squared plus imaginary part squared. So if you see here, in case of numerator, if you see, this 2 is the real part and this omega is the imaginary part. So you get magnitude as, yes, root of 2 squared. What is 2 squared? Is 4. So 4 plus omega squared, which is nothing but the magnitude, right? Divided by what is the denominator? If you see, it is going to be omega cube is going to be the magnitude of the denominator, right? Yes. Now if you think of angle, what is phase? Phi. Phase phi is going to be what? Yes, this one. If you think of the numerator only, then you get tan inverse of imaginary part upon real part. What is imaginary part? Imaginary part is omega by 2, so it becomes tan inverse of omega by 2, right? Now minus what? See, you have got this minus j. What does this minus j indicate? If you see, if you have this one, this is, for example, if you consider this one as j, right, then this is j squared and this becomes j cube, right? So if you just see that you have got this one as minus j is where minus j is going to be, this indicates that the angle is nothing but, or this j cube indicates that 270 degrees rotation. So 270 degrees rotation in c, so this means that 270 degrees rotation here in anticlockwise, which means it is going to be plus 270 degrees, right? Plus 270 degrees. If you remember, we have seen that already. If you remember, see, if this is real part, right? So here I have this I, or we can say j, and here we have j squared, then here we have j cube, then again we have j to the power 4, and so on. It just goes on and on. We have studied this in mathematics, right? Yes. So if you think of this j cube, how much does angle it make with the positive real axis? The angle it makes is going to be, yes, either it is going to be plus 270 degrees, right? But now this is because it is in the denominator, it is going to be plus 270 degrees, but this particular angle, if it goes up, then it becomes minus 270 degrees. So here I have to consider minus 270 degrees. These basics have been already taught, right? Now if you think of phase phi, it is equal to what? Phase phi is going to be tan inverse of omega by 2 minus 270 degrees. Is that correct? Yes. Now if we think of step 1, yes, if you think of step 1 is what? To find the m0 and m infinity. What is m0? Again, m0 is nothing but magnitude at omega equal to 0. If m is magnitude at omega equal to 0, it means under root of 4 plus 0, which means it becomes under root of 4 plus 0 divided by 0, which means it is going to be equal to infinity, because anything divided by 0 is infinity. The next is m infinity. M infinity is going to be magnitude at omega equal to infinity. So if you just replace that in the magnitude equation, you get under root of, what is that, 4 plus infinity divided by infinity. Is that right? So again, here if you see, you will be getting this infinity by infinity form, which is the indeterminate form, right? So in such a case, what we do is we just take that omega square common. So if you see that this m which we have is nothing but 4 plus omega squared by omega cube, our original equation, right? So if you think of, if you just take this omega square out, some means, so if I take omega squared common outside, I get omega divided by 4 by omega squared plus 1, right, divided by omega cube. This omega will get cancelled, this becomes omega squared. Now if you replace m infinity, if you replace omega is infinity, so this becomes infinity, this becomes infinity. So it is 4 by infinity, 4 by infinity is going to be 0, 0 plus 1 is going to be 1, so it becomes 1 by infinity, and 1 by infinity is going to be 0. So what do you understand? You understand that m infinity is going to be 0 from here. That is what we have seen. Yes, with practice and all, you can do that very easily. This is for your starting, so it's okay, because at your home you have to practice and practice, because practice is the key. Without practice, it is impossible to score in gate. Anyways, step 2 is what? To find the angles, to find the phase at 0 and infinity. So if you think of phi 0 is what? It is equal to what? Phi at omega equal to 0, right? Yes. So if you see, how much is that? That becomes tan inverse of 0 minus 270 degrees. Tan inverse of 0 is 0. So your phi 0 becomes minus 270 degrees. Is that correct? Yes. What about phi infinity? Your phi at omega equal to infinity, which is nothing but equal to tan inverse of infinity minus 270 degrees. What is tan inverse infinity? It is going to be 90 degrees, right? Which is going to be nothing but 90 degrees minus 270 degrees, which is nothing but minus 180 degrees, right? So you have actually seen this phi naught and phi infinity. Now our main thing, ending direction and starting direction. So if you think of step 3 is what? Ending direction, right? Ending direction, ed. So what is that? That says that phi infinity minus phi 0. Phi infinity is what? minus 180 degrees, minus of 50 is what? Minus 270 degrees, right? Because minus 270 degrees. So minus 180 degrees plus 270 degrees is equal to what? Minus 180 degrees plus 270 is going to be 90 degrees plus 90 degrees, which is what? Positive. If it is positive, then we have seen that it is anti-clockwise direction. So the ending direction, if you think of ending direction, is going to be anti-clockwise direction. How about the starting direction? Step 4. Right. If you think of the starting direction, how much is the starting direction? For that, let me just draw the pole zero plot. Yes. What was the loop gain? Loop gain was s plus 2 upon s cube. By the way, note, this is not the pole zero plot for the overall transfer function. This is the pole zero plot for the loop gain. Right. We have already talked about in the introduction video that why loop gain is important for us. Because in the characteristic equation what you have, that is nothing but 1 plus gh, right, equal to 0. So there it comes. So with that also everything can be sufficed anyways. So if you think of the gh equal to s plus 2 by s cube, so if you have that here, then you see that this s cube indicates that 3 poles at origin. So at origin you are going to have 3 poles, so 3 poles are drawn at origin. Then s plus 2, which means you have a 0 here at minus 2. S equal to minus 2, you are going to have a 0, right? So according to our rule, whatever is there on imaginary axis as well as on the right half, we have to ignore, right? So we are interested in only this one. So if 0 is closer to origin, 0 is closer to origin, which means starting direction is what? Anti-clockwise. So starting direction also we have got, which is nothing but anti-clockwise. Now let us draw the polar plot. So the polar plot looks like, yes. So if you see at omega equal to 0, what has happened? At omega equal to 0, magnitude was infinity, right? And how much was the phase? Phase was minus 270 degrees. So it has to be here. If you see, starting direction is anti-clockwise direction. So it has to move in this direction only, anti-clockwise. Anti-clockwise is this direction, right? Anti-clockwise is this direction only. So this one, if you see this way, so it becomes anti-clockwise only, right? So that's the direction. What about ending direction? Ending direction is also anti-clockwise. Ending direction is also anti-clockwise. So ending direction is here, which is anti-clockwise. Is that correct? So this is at omega equal to 0 and this is at omega equal to infinity. I hope you have understood these points. So in this way we have seen that what happens with addition of zeros in the transfer function or in the loop gain, to be specific. We have also solved one example wherein we have taken everything, wherein we have seen that we have considered 1 0 and we have considered 3 poles at origin and we tried to find the plot for the same. Thank you.